Hello everyone, welcome back to my Core Java interview questions playlist. If you have been following along, you know we have already covered 6 key videos on Java fundamentals, object oriented programming, string class, exception handling, multi-threading, and part 1 of the collection framework. In the part 1 of collections framework interview questions, we have already covered questions on list, set, hash maps, etc. Today we are diving into part 2 of the collections framework interview questions. In this video, I'll walk you through some of the most commonly asked interview questions on Java collections and provide you with precise interview ready answers. Whether you are preparing for your next job interview or looking to strengthen your Java concepts, you are in the right place. So grab your notepad and let's get started with the next set of important questions and answers on the Java collections framework. So first question in this video is hash map versus weak hash map. So weak hash map is a special implementation of map where the keys are held using weak references. This means when the key object is no longer strongly reachable from outside the weak hash map, the entry can be automatically removed by the garbage collector. Hash map on the other hand holds strong reference to its keys. Next question is hash map versus concurrent hash map. This is again very important question from the interview point of view. So in hash map is a non-thread safe, but concurrent hash map is a thread safe. Hash map is not synchronized, but concurrent hash map is synchronized. Hash map is present in Java's traditional collection framework, but concurrent hash map was introduced in Java's concurrent collection framework, or we can say concurrent package. So HashMap was introduced in Java 1.2 and concurrent HashMap was introduced in Java 1.5. Another difference is HashMap allow one null key and values, but it is not suitable for concurrent environments, whereas concurrent HashMap does not allow null key or values and it is designed for to be used in multi-threaded environments. So these are some few differences of HashMap and concurrent HashMap which can be answered in the interviews. Next question is explain internal working of concurrent hash map. This is again very important question and can be asked in your interviews. So the concurrent hash map divides the map into segments, which is default 16. So each segment acts as an independent hash table. So when a thread writes to a segment, it locks only that segment, allowing other threads to access other segments simultaneously. This contrasts this contrasts with hash table or collections or synchronized map, which locks the entire map. So it uses lock striping technique. Instead of logging the whole data structure, it locks a particular part of it. So we will see the read operation working. So for reading there is no locks required. It uses volatile variables to ensure visibility of most recently updated values. It returns the latest committed value even if the concurrent writes are ongoing. So whatever latest committed value is there, it returns that. For write, we are using put method or remove method. First thing is hash calculation. It determines the target segment. Then segment locking. It acquires a lock on that specific segment. Collision handling. It is similar to hash map. It uses linked list or tree structures from Java 8 plus for collisions. Resizing. So whenever like the load factor exceeds the threshold, segments are resized independently. Next question is explain internal working of HashSet. This is again very important question. HashSet basically uses a hash map internally to store the elements. So elements become hash map keys and a dummy value is assigned. Basically this present dummy value is assigned for keys. When we call the add method on the hash set, it internally calls put e, which is the our object key, and present, which is a dummy value on the underlying hash map. If the key element does not already exist, it is added and the method returns true. Otherwise, it returns false, ensuring the uniqueness. The hash code of the element used as key determines its bucket location in the underlying array of the hash map. If two elements have same hash code, then they are stored in a linked list or tree structure at that bucket. And equality is checked using the equals method. This is same as the hash map only. So it offers fast average case, which is O of 1 performance for add, remove, and contains methods or operations. Another question can be asked is explain some method, give some methods of HashSet. The first is add method to add the element if it is unique and not already present. Remove, it removes an element if it is present. Contains, checks if an element exists. Size, returns the number of element. Is empty, checks if the set is empty. Clear, remove all the elements. Iterator, returns an iterator for traversal of HashSet values. Now this can also be asked how to iterate over hash set elements. So we can use an iterator or enhanced for loop to iterate through elements, but there won't be any specific order. So here we can see there is one hash set named as my set, and we are adding apple, banana, and cherry. So first way is using iterator. We are using iterator of string type. This is generics. We'll see it in the upcoming slides. Uh, Object name is iterator, and we are using my set dot iterator method. Then while iterator dot has next, we are getting the element and we are printing that element. This is one way. Another way is by using enhanced for loop. So we can use string element in the my set, and it will print all the elements one by one in the loop. So this can also be asked as a tricky question. Can we get element at specific index from hash set? So we cannot directly access an element at a specific index from HashSet in Java because HashSet does not maintains any order of its element and does not provide a get index method. The elements are stored based on their hash codes and the order can change over time. So there is no guarantee of consisting or meaningful index. So if we need to maintain any insertion order, we should be able to use linked hash map, or we can convert that linked hash set, or we can convert that linked hash set to an array list instead. So linked hash set preserves insertion order, so converting it to a list or array will reflect the order in which the elements were added. How HashSet handles duplicate values? So HashSet is designed to prevent duplicate values. When you attempt to add a duplicate element, the HashSet checks for its presence using hashcode and equals method of the object being added. If an object with the same hashcode and equality is found, the new element is not added and the add method returns false without throwing any errors. So this is important to note here that it does not throws any errors, it just simply returns false. Okay, so this is again very important practical question. This can be asked in interviews for experienced candidates like 3 to 4 years of experience. If there is an animal class, this is our own custom class with id, name, and other attributes, and we have to use this class as a key in hashmap, and the value would be its name. How can we achieve this? So basically, to use our own custom class as a key in hashmap, we must override both equals and hashcode methods in our class. This ensures the correct behavior when storing or retrieving the object. Okay, so see, for example, this is our class animal. We are having private final int id, then string name. There might be other attributes. We are having one constructor here to initialize the values for id and name. Okay, now this is the important part here, and this is what the interviewer is expecting. So we have to override hashcode and equals method. So first we are overriding the equals method, which is accepting one object. First condition is if this, that means the current object is equal to the object being passed for comparison, then returns true. So basically this is the case where both the values are same. So basically it is same object which we are trying to compare. So it returns true from here. Or else if the O, like the object which is being passed for checking the equality, is not an instance of animal class, then we have to return false, because if it is not an instance of the class, then how it will be equal. And then if these two conditions are not met, then we are storing the object received for the equals parameter as a parameter in the equals method. We are storing it as a animal object by typecasting it, and we are returning on the basis of id. So return id equal to animal dot id. So it will be checking equality on the basis of id. Similarly, we are overriding the hashcode method and we are returning integer.hashcode and we are passing id because we are here, we are comparing on the basis of id. So the hashcode should also return the id only. Now adding the data to HashMap. So say we are having a map here which is expecting key of animal type and value of string type. We are naming it as animal map and we are creating new hash map. Animal a1 equal to new animal. We are passing it values such as 1 is the id and name is lion. And we can put something like animal map dot put a1 comma a1 dot get name, which would return lion. So this is how we can achieve this problem statement. So the key thing to note here is that we have to override hashcode in equals method, and this is the exact way of doing it. Now another important question is explain contract between hashcode and equals method. So we seen in the earlier slide that if we are overriding the equals method, we are overriding the hashcode method as well. So why we are doing it? So there are some contract between hashcode and equals method in Java. It ensures the correct behavior when objects are stored in the hash-based collections like HashMap, HashSet. Okay, so the contract is as below. If two objects are equal according to equals method, they must have the same hash code. Okay, if two objects have the same hash code, they may or may not be equal according to the equals method. Third, if you override the equals method, you must also override the hash code to maintain its contract. So this was the point which we have seen in the earlier slide, that if we are overriding the equals method, we have to override the hash code as well, so that its contract is maintained. Fourth, the hashcode method must return the same integer result on multiple invocation for the same object. So it should be idempotent unless and until object state is changed. Okay. So these four are the point which ensures the contract in the hash-based collections. So this was a weird question which was asked in one interview, that give one example where the hash code is same but the value is different. So I was not prepared at that time, but after the interview I have checked how this condition can be met. So this is one of the condition where we are having two string. One is a small a, another is both capital B's. Okay, so if we print the hash code of these two, the hash code will be 2112, 2112. But if we compare the hash code, it will return the true because both the hash codes are same. But if we check the equality of the content, then it will return the false. So this is the point number 2 here. If two objects have the same hash code, they may or may not be equal according to the equals method. Okay, I think we have covered all the collections classes and interfaces, but this is again an integral part of collection only because iterators are generally used to iterate over the collections only. So this is the again important question where which is explain difference between fail fast and fail safe iterators. So basically fail fast iterators throw concurrent modification exception when one thread is iterating over collection objects and other threads structurally modify the collection either by adding, removing or modifying objects on the collection. So they are called fail fast because they try to immediately throw the exception when they encounter a failure. The example of fail fast iterator is iterator. And on the other hand, fail-safe iterators does not throw any exception if the collection is modified structurally while one thread is iterating over it, because they work on the clone of collection instead of original collection, and that's why they are called as fail-safe iterator. Example of it is enumerator. Okay, so how can we avoid concurrent modification exception? This is also very important question. So there are two ways. One is by using synchronized blocks. Another way is by using concurrent collection. We'll see both of them one by one. So we can use synchronized block to ensure that only one thread can access and modify the collection at a time. So we can see here we are having one list of string type and we before starting the getting the iterator of it, we are synchronizing the list. So whatever block, this block is synchronized, so at a time only one thread can be able to access it. So there is no possibility where one thread is accessing the this list and another thread try to modify the list by adding or removing element. So this is how we can avoid the concurrent modification exception here. Or else we can use concurrent collection. So we can utilize Java's concurrent collection like copy on write array list on or concurrent hash map. These collections are designed to handle concurrent modification safely. So for example, if we again define one list and we are using a new copy on write array list, so whenever we are using iterating it using enhanced for loop, and if element like safe modification can be done here, because whenever there is a modification we are working on copy only, so it is not actual list with from which the element is getting removed. So this is another way by which we can avoid concurrent modification exception. Okay, this is a important question from interview point of view. Difference between iterator and list iterator. So the traversal, let us understand them with the help of features. So first feature is traversal direction. So iterator traverses in the forward direction only, whereas list iterator can work on forward as well as backward traversals applicable to. So iterator is applicable to all collection types like list, set, queue, map, etc. But iterator, as is its name suggests, it works on only list implementations. We cannot add element using iterator, but we can add element using list iterator. We cannot modify the element using iterator, but we can modify the element using list iterator. So we cannot access the index using iterator, but list iterator provides supports for accessing the indexes like next index or previous index methods. This is a important concept in Java. What is generics? So generics is in Java is a feature that allows you to create classes, interfaces, and methods with a placeholder for the data type. So we have seen here iterator of string. So here string is a generic, okay, because we are passing the data type here. And below are some of the key features for the same. So type parameterization. So we can specify a type parameter like T, so your code can operate on different data types as needed. Another important use case of it is code reusability. So we can write one class or method that works with any data type instead of duplicating code for each type. Third and very important feature is type safety. So generics allow the compiler to catch type errors at compile time. It reduces the runtime errors and eliminates the need for explicit typecasting. So this is the most important feature, that it eliminates the need for typecasting. What is wildcards? So in Java, wildcards is represented by the question mark symbol. It is used in generics to denote an unknown type. So wildcards make generic code more flexible by allowing you to write methods, classes, or interfaces that can operate on different types without knowing their exact type at compile time. Some key points about wildcard is syntax of it. The wildcard is written as question mark and it is used in generic type arguments like list of question mark. Here we are not giving any type of it, any type for list. Second, the purpose of it. So wildcards allow you to specify that a method or class can work with a family of types, not just a specific one. For example, list question mark can represent a list of any type. Third is types of wildcard. So we are having unbounded wildcard, which is represented by question mark. It represents any type. For example, list of question, it can accept list of integer, list of string, etc. Second is upper bounded wildcard. So here the syntax is question mark extends type. So it restricts the unknown type to be a specific type or its subclass. For example, if we are having list of question mark extends number, so it can accept list of integer, list of doubles, etc., but it won't accept the list of string. Then there is lower bounded wildcard as well, which is the syntax for it is question mark super type. So it restricts the unknown type to be a specific type or the super class of it. For example, list of question question mark super integer. So it can accept list of integer, list of numbers, or list of objects, but not the subclasses of it. That's it for today's session on Core Java Collections Framework Interview Questions Part 2. I hope you found these questions and answers helpful for your interview preparation. If you enjoyed this video, don't forget to like, comment, share, and subscribe to the channel so you never miss an update. Stay tuned. In the upcoming videos, we will be covering more crucial Java interview topics, including interfaces, abstract classes, Java 8 features, and much more. Thank you for watching, and I'll see you in the next video.